You're doing number 3. I'm doing number 2. Elena, what we're going to be doing first is we're going to be going back to some of the work from yesterday. So we're going to go on page 99. I asked them to do questions 1 and 3 at home. Those that didn't finish it. And then I also asked them to do 1 and 3 on page 101. And I also asked them to do 1 and 3 on page 105. Okay. So if you'll just bear with me for just a second, we're going to kind of go over those problems first, and we'll go over the new problem. All right. Those of you that are supposed to be back in the back first. Okay. Remember yesterday we switched it up so you could find your vectors. So if you would take the paper, and I'll talk to everybody at one time. The paper that you have on your desk that I gave you is using Google Earth. Does everybody know how to use Google Earth? Okay. So what you're going to do is you're going to go back in the back. Today's work is individual. Okay. So you're going to sit across from each other, parallel to each other. Okay. If you feel comfortable sitting next to them, I don't care. So what you're going to be doing is you're going to be working on the Google Earth paper. Okay. It's a handout that you have to fill out. So you would have to take a picture of that to submit however far you get. Okay. So y'all go back there. Everybody else up here. We're going to start on page 99 and we're going to do this problem.
Paper, pencil.
Okay, so we're going to start on page 99. Are you going back there right now? Okay, well then just wait, that goes there back there. It's okay. Sorry. All right, so we are going to start on page 99. Now, those of you that did not get the formula, I have written it on the board for you. Right, guys? So if we look at question number 1, on page 99, it says a ball rolls off at a 0.70 meters high desk and strikes the floor at 0.25 meters away from the desk base of the desk. How fast was the ball rolling? So change in y is 0.70 meters. Okay, negative mark because it's going to be rolling off, right? Change in x is it fell off the desk, right? 0.25 meters. In these type of scenarios, we always have to look at the acceleration of y. The acceleration of y would be gravity because it's falling down. The formula that we're going to be using is our velocity of our x position, correct? So we're going to do square root. So let's fill this in. So the square root of acceleration of y, which is gravity, 9.8 meters per second, over 2 times the change in y, which is negative 0.70, and that's in meters. And then the change in x, which is 0.25 meters. Plug that into your calculator. And I will come by and look at your calculator. Now, does it matter what mode we're in here? Are we doing degree? Okay. Yes, sir. Huh? I'm assuming Google Pro, because that's what that says, isn't it? On the paper? Okay, then Google Earth. I don't know which one you use, to tell you the truth. Okay. Now, well, hold on just a second. Hold on, sir. Just a second. If you are square rooting, can you square root a negative? No. What happens if you square root a negative? Gives you an error. Okay, I'm coming back. When I come by, show me your calculator. I'll be back to you in a minute, ma'am.
Okay.
Thank you, guys. Okay. Now, I see you, you're doing great. You're following exactly what I have here, okay? Now, some of you might have already done this already. This is outside, okay? Are we good now? Checking. It is a difference, isn't it? Okay? But if you looked at the formula, where's that supposed to be at? Cool. Okay. Everybody good with number 1? Okay. You did number 3, but I have number 2 on the board. Okay. So here we have the question. The question number 2 says a cat chases a mouse across a 1.0 meter high table. The mouse steps out of the way and the cat slides off the table, striking the floor at 2.2 meters of the edge of the table. The cat slid off the table. What was its speed? So are we trying to find the same thing? Are we trying to find the same thing?
Play some of the ants.
You good, baby? I'm sorry. All right, is this the same problem? Same thing we're trying to find? We're looking at the cat, right? All right, so here we are again. Square root, right? Gravity. I'm just going to not do negative. Is that okay? Because it just messes me up if I do that. I'm trying to put it in the calculator. All right, we're going to do that over 2 times. What's the change in y? Okay. And then what is our, and then what's our x? Okay. Go ahead and put it in your calculator. I'll come by and check. It's a unit. Yeah. All right, so let's see what we got. See that. Yep, 4.8. Doing your steel. What did you get? Yep.
Y'all got 4.8? No, 4.86. Or, yeah.
7. Yeah. I said, yes. Yes, it is, 4.87.
There's a two. Where are you using it to?
Okay, so what I did is I did a square root of 9.81 over 2 times 1.0, close bracket, go over 2.2. And I get 4.8723961. Did everybody get that number? Now, you gotta move this over with square root. Oh, okay. So when you do your alpha y equal, and you put your top and your bottom, make sure you use your arrow over enough so you get your bracket. Okay. So what I have seen is just one problem. The only problem that I see is when you put it in the calculator, when you have your alpha y equal and you put your fraction in, make sure you move it over enough. The square root is only going for that before you open your bracket and do your 2.2. Is everybody good? Good. All right, so let's look at number 3. Number 3 says the pelican flies along a horizontal path and the fish with a height of 5.4. The fish traveled 8.0 horizontal before it hit the water below. What was the pelican's speed? All right, so are we using the same formula still? Yes? Okay, so is it all right if I just erase this one? Okay, I should have just kept that. Okay. All right, so what is my change in y? Okay, what's my change in x? 8.0, right? Meters? Everybody good so far? Okay, we're going to do the same thing as what we've done before. So we're going to do Vx equals square root. We're going to have 9.81 meters per second squared over 2 times the change in y, 5.4. And then over here, we're going to do 8.0 meters. All right, so what did we get? You got point what? 24.11.
Yeah, but the change in y is supposed to be negative 0.2.
Yeah, it is supposed to be negative, but I'm not going to put it in. I'll put it in there. I'll just forget. I'll make sure that I understand. I got you.
That's the whole point, supposed to be like so 0.2.
I have a problem with my ears today. One's clogged up, the other one's echoing, so I apologize, Christopher. Okay, Christopher, I'll go back to this, and it's okay. Listen, I'm all the time, Christopher. That's all I can tell you is I'm all the time. Okay, so is everybody agreeing with this number, or is it different? Okay, what is my answer?
7.6.
Thank you. That's what I got, 7.6. All right, are you ready to do number 4? Well, what are we trying to find? We're trying to find the velocity of x. Okay. Now can we go to the next page? Okay, let's go to the next page. Okay. So on page 101, question number 1 says the measurement made at 1910 indicate the common flea is impressively a jumper, giving its size. Assume that the flea's initial speed is 2.2 meters per second and it leaps at an angle of 20 degrees with respect to the horizontal. If the jump lasts 0.16 seconds, what is the magnitude of the flea's horizontal displacement and how high is the flea that jumps? Right, guys? Okay, can I erase this? All right. All right, so let's look and see what kind of variables that we've got first. First one, we have velocity initial, and what is that? 2.2 meters per second. Oh. No, I think that my stress level is up pretty high. And so My dyslexia and everything else is just, I'm a mess. That's all I can say. I'm a mess. Okay, so I have everything up here already. So the first thing we're going to do is our velocity initial is 2.2 meters per second, right? We're going to use a cosine. Our angle is 21. We want to make sure that we change our calculator to degrees, right? And then we're going to change in time, which is 0.16 seconds, right, guys? Okay. Is that numbers right, guys? Fantastic. Okay. So change my mode first. I'm in degree. I'm good. So I'm going to do 2.2 cosine 21. Close my bracket and 0.16. What'd y'all get? Anybody else get anything different?
What'd you get? That's probably low. What did you get, Miss Long?
I got 0.386203.101. Scientific. I mean, excuse me, degrees. I have to laugh at myself because I want to cry right now.
I didn't put 0.175. I didn't put 0.75 out there. 175.
Thank God we're not having a test today. So what is my answer?
16 seconds. Point.
It's 16 seconds.
Where do you see 16 seconds?
Oh, that's it.
Oh, yeah. That's 0.1. Okay, it's 5. Me too. Oh, it's, oh.
We can make it see it.
Yeah, that's it. Yeah, that's it. Okay. So what you could do 0.33, right? Are we all good with that one? Fantastic. Okay. Are we ready for number 2 now? Are we? No, I'm sorry. We're doing number 3, aren't we? Okay.
What's, I thought it was 2 questions.
What, babe?
Because it says if the jump lasts 16 seconds, what's the magnitude of the plane's displacement? How high is it?
Okay. So did we find out how high he jumped? 0.33 meters, didn't he? But what else do you want?
What's the horizontal?
And I thought we just found the displacement, but how long is it?
Okay, are y'all ready then? She asked. Okay, second part. I love people that are on task today. No, we're okay. You're good, baby. Why are you complaining?
These people mad at me.
Don't be mad. Okay, so we're looking for how high he jumped, right?
So this is the first one.
The first one was the displacement, yes, ma'am. Okay, so to be able to do that, a velocity initial was 2.2 meters, right? Okay. We had 21 degrees. All right. Our change in time was 0.16 seconds. Our AY was gravity. Our change in T was 16 seconds again. Okay. Now the question that I have for you, if I gave you this, could you do this? That's all we're doing.
Yeah.
I'm giving you this on the test. You got to do this. Okay. So let's see what we got. That's 0.16, by the way, guys, no seconds. I mean, no S. No 5. That's what I mean.
We do square the last.
Yes, ma'am, you do. Because that is not a unit of measurement. That is in the formula itself.
Is the square in the?
It is on the outside of this 0.16 divided by 2. What did you get?
I got 6.33.
I got 0.09.
I got 0.09.
This inaccurate. The top. Oh, I put 16 up to not 0.16. You already got it. Well, I thought it was 0.09.
Yeah, I got 0.09.
You're right.
But if I go in, are you ready? If I go in and put my brackets around, then I get 0.063. But I think I say it's 0.09. 0.0944647591. Is that what y'all got?
Is that baby?
Okay. Now, are you ready? Do you have your answer in your calculator? Let's change it to scientific. Yeah, let's do it. Mode, because it's a negative number. I mean, let's change it to scientific. It's in the mode section, ma'am. Keep it there. And now do second answer, enter. What do you get? No. Okay. We're having a great time here today. So if I took my answer and I changed it to scientific, it should have smoothed the decimal over.
Yeah.
So just wait. You did that? Yes? Did you do that?
I did, but I had the wrong answer.
Okay, cool. Did you do that?
I had to clear mine out. Yeah, behind.
Did you do that? This is important because we're not done yet.
Oh. Oh. Oh no. I just figured
No, you don't.
the whole thing out twice.
Okay, so after you get that done, that is going to change in your change in Y max, right? Now we have a number already. This is the maximum height that he could be. Okay, so I'll put that number down that I have, which I hope somebody has. Is that the number that you have? Now I'm going to subtract that by 3.1 times 10 to the negative 2. Where am I getting this from?
I had 6.3.
Well, you were fine then.
I know, but then now it's talking about 0.9.
Okay. So let's park here for just a second. First thing I want you to do, those of you that just gave up, first thing I want you to do is I want you to put that calculation in the middle, back in your computer again. Sounds that's in your seat, is that okay? Okay, I'm not gonna sit. It says that.
I don't understand how I have it.
Ma'am, just put it in your calculator.
While it's in scientific,
Yeah, keep it in scientific, that'll be fine, because then we don't have to change the mode.
this is what you do in this estimate. I still keep getting the same thing, so. What you get? Well, I got 1.32 again.
Me too. From you, calculator.
What you doing this afternoon?
Right now, I'm doing your math, so that's what
Well,
we're doing.
this afternoon, you should come to my game. Oh, yeah. Mine.
Yeah, her game, not
Okay.
Just put it in. I got
Okay, so open bracket, 2.2, close bracket, open bracket. 2.2. Close bracket. I'm doing science.
Yeah.
And that's 20. Close bracket.
But that doesn't go in brackets, because
No.
you put it in there. Look.
Go ahead and change it.
So I got 9.44. All four of us got it back here in this corner.
Oh,
I'm doing it again on work after. I don't know what.
Yeah, that's not good.
Come on over here, girlfriend. 0.16 over 2.
I got 6 more.
Close my bracket. Plus, are you doing the half, guys?
Yes.
I'm still got 9.4. I just think this calculator is not really good. You're even,
Can you
you're
go,
off and I was.
can you go? Hand me mine. We can definitely work this one. Okay.
I'll figure this thing out.
I'll just square it with this. Well, somebody tell me, wait, the answer's 9.443?
It changed from 6 to 3 and we did it inside of it, you know.
Oh. Yeah. What happened is I squared the whole thing. And I also squared the 16. So mine is wrong.
So that's the inside of the bracket.
No, you're right and I'm wrong.
She squared, she did everything.
What I did is I did everything that y'all did, except what I did was I did that to get this number. And so I'm wrong. Y'all are right. I apologize. So your answer is correct. My answer is wrong.
Mine is still wrong.
I got 6.6.
Okay, so the three geniuses in the back From this side over here, not including you, because I love you. What did you get? Okay. What did you get? What did you get? You gotta be the third genius. Come on.
Same thing.
Okay, cool.
Why don't you ask me?
Okay, what did you get?
Not that.
I got these.
All right, so can we continue on with question number 3 now?
Yeah.
Do we care how far this little flea has actually leaped down? Do we care? I don't care. I got half the credit and I'm good. All right, are we ready for number 3?
Next time I'm gonna ask.
No, you should have asked. You should have asked, but not.
Yeah. I'll just forget.
Okay. All right, number 3. A baseball is thrown at an angle of 25 degrees relative to ground at a speed of 23.0 meters per second. If the ball is catched at 42 meters from the thrower, how long was it in the air? How high above the thrower was the ball that traveled? Okay, so we have our change in X, right, guys? Please say yes or no or something. Okay, cool. What is our change in X? Just bear with me for a second. All right, what's our angle?
45.
We can all agree on that one. All right, what is our AY or our gravity? Okay, what is the formula we're going to use? What are we looking for?
Oh,
How long was it in the air and how high above the thrower was?
Okay, so what formula are we using?
Wouldn't it be? I also do not. Would it be-
Bear with me one second. I didn't do 3 in here.
Miss
She is busy.
I got a question. I went on Google Earth and I was doing my little measurements. My screen was blank. Throw and the screen still flat.
Did you shut down and restart back up?
Yes.
Okay. And Google Earth is down?
Yes. But
Okay,
everybody else.
okay. Well, I don't know even what to tell you.
I think you need to plug your computer up. That fixes all problems.
I just like it.
Look at that,
That's
dog.
in the hand.
Okay,
Just say it.
all right, thank you, Josh, for analyzing and
The problem was,
doing what you need to do for me today.
I'm trying to do what I need to do for today. but my computer's
All right,
Yeah, like me. That's-
yeah. We are doing number 3, correct?
Mhm.
Yeah, I'm looking. I don't even see it.
I'll do it.
Well, come on up.
Oh, I was just kidding. I'll get the.
Please do not, well, you know what? Either way, we're gonna get the wrong answer. It don't matter.
I mean, I never got the wrong answer.
I'm trying to find out. I can't even find it on here. I don't even know what those are. That's not it.
Oh,
Can we skip number 3 for right now and go to the next page? Just Miss Sloan doesn't have it. And she didn't even work the problem. Okay. And I can't find the book answer. All right, question number 1 on 105. Let's see what we can do here. Let me see if I have the answer first. Question number 1. We're not doing question number 1 on the 3 of the other one, but I'll do it on this one. Okay, I got both those answers. Praise God. Hallelujah. All right, so it says, George V. Coast of Antarctica is the windiest place on the earth. The wind speed there reaches 3.0 times 10 to the second power kilometers per hour. If a research plane flies against the wind with a speed of 4.50 times 10 to the second kilometer per hour related to the speed, how long does it take for the plane to fly between 2 research stations that are 250 kilograms apart? Okay, so I'm going to use abbreviations. So we're going to figure them out as we go. Are we ready? This one's going to try to make it through this one. Oh, that's right. I didn't even set the timer, so we're all good. I can have you all day. All right, so I'm going to go to the Google word. Okay, well, you know. All right, so God, that's not black. Okay, what is this? Velocity of what?
Velocity of the wind. Wind speed. The high.
Okay, wind and what else? My day is going to be better than this after I get finished with this chapter. Okay. All right. So if I look at the formula, my 3.0 times 10 to the second is the wind speed there, right? So this is the wind speed, the velocity of the wind speed. 4.5 times 10 to the 2, that is the wind with the plane, research plane flies against the wind with the wind speed. So this is the plane against the wind speed. Are we good so far? Okay. The change in X, we know what that is. That's position, right? What are we looking for? How long? We're looking for change in time. Is everybody good? Okay. All right. So we are going to take this and add it to this. We're adding both of these together. Why are we adding both of these together? We're looking for the velocity of the plane and the earth. This is the wind and the earth, is what I'm going to say it is. And I'm going to say this is the plane and the wind. Are we good so far? We're adding, so we're not doing a square root. So the answer to that question is
Yes.
Thank you. Okay, so 4.50 times 10 to the second kilometers per hour. And we're going to add that to our negative 30 times 10 to the second kilometers per hour. Okay, what answer did you get? times 10 to the second kilometers per hour. So now we've got using both of those, the plane and also using the wind, okay? And we've got our number. Everybody good so far? We are looking for change in time. To find change in time, we're going to do position over the velocity of the plane and the earth. Everybody good? So the change in position is 250 kilometers divided by 1.50 times 10 to the second kilometers per hour. Now, with these variables that you see here, you can use any variables that you want that make sense to you. When I did this problem, these variables made sense. When we're talking about forces acting on other forces, this is kind of premature because we haven't talked about forces and how to label them yet, right? I'm already using it, but when we get to the forces part, you understand. This is what's acting on by what. Okay? That's what this is. Everybody good with this answer? No, ma'am, I didn't. You talking about here? Yeah. Yeah, because it's not, yeah. So what answer did you get?
6, 7 times 10.
Sounds good. That's what I got. We rounded it to a 7 because of the other number. Are we good so far? Okay, can we do number 3? And then I'm going to release you. It'll be time to go. Y'all in the back, come in the front. Those of you in the front, go in the back. Go on. We won't do the other one. God knows, I think I've spent an hour and a half with you. That's what it feels like. Yes, ma'am. Elena, I love you. You can go. All right, baby. With the test tomorrow, I'll post it online for you. All right, baby. And then you can just do it and do the test corrections. I didn't give them test corrections. I can send you the picture of your test. I've already graded it and I already put it in the grade book. What I did with you and what I took off for you is the one section that told you to graph and you didn't graph it. If you want to graph it and get the 5 points, please graph it. I will see you tomorrow. Thank you for coming. Oh, hey, Gabriel. I didn't know you were here. Yep. Can you text me, please, in the comment box? Ooh, I can hear you talk.
Yeah, you kind of ignored me.
How are you doing today?
I'm doing good. How are you?
I'm doing great. I'm sorry it was such a debacle today, but how long were you on for? Because I only saw Elena for a while.
I've been here since 9 o'clock.
Have you been? You get an extra point today. All right, baby, because you were here for 41 minutes.
Yes, ma'am.
All right, so are you going to be home tomorrow?
Yeah, I'm quarantined.
Okay. So I will put the test up for y'all, and then you can do it and just submit it to me. Now, since Elena's already been before and you have not, the way that the test works is I do it live. When the kids get it, you get it, and you have to turn it in by the end of class.
Yes, ma'am.
All right, baby. And the only thing you got to do is just make sure on your ISM book you put your name on the top so I know whose it belongs to. Because what I'm doing is I'm printing off the test, and then after that, I am grading it, and then I'll send it back to you. All right, baby?
Yes, ma'am.
Thank you for coming.